In this video, we're going to learn how to simplify expressions. So recall from Unit 1 that simplifying an expression means to rewrite an expression in the simplest form possible. Well, what is the simplest form possible? We said in algebra, this means performing any operations possible. So we saw in arithmetic, simplifying basically means performing the indicated operations. Any operations you have, you perform those operations, and then usually your result is a single number. Okay. Now we saw in algebra, we cannot always perform every operation. So for example, we have the expression 2x plus 3. There's still an addition symbol here. Okay. So we'd like to add 2x plus 3, but 2x and 3 are not like terms, and we don't know what x is, so we cannot perform this addition. So 2x plus 3 is as simple as we can possibly make it. Okay. So our goal is to perform every operation until we can perform any operations anymore. Okay, so combining any like terms. Now, we use the distributive property to justify how we combine like terms, and now we're going to use it in the other way that we had looked at. So for example, if we have the product of 2 times the sum of x and 3, okay, right now we have the x plus 3 in parentheses. We don't know what x is, so we can't perform this addition first. But we learned using the distributive property that we can distribute the 2 to the x and the 3, multiplying 2 times x plus 2 times 3, multiply the results, and we have 2x plus 6. So we would consider 2x plus 6 to be the simplest form. The product of 2 and x plus 3 still has a product in it. We can still multiply that, and that's possible because of the distributive property. However, when we get to 2x plus 6, this cannot be simplified any further. Okay? And remember, there's an equivalent form with subtraction. So if we have subtraction, we can distribute the same way, but you keep the operation of subtraction instead of addition like we did in the previous example. So let's look at some problems. So the directions read, simplify the expressions completely. And just a note on this, lots of times we'll just write simplify, and simplify means to simplify the expressions completely. So we don't mean just perform some of the operations and make it more simple. We always want it to be the simplest, even if we don't put completely. Okay. So here's our strategy. I'll write this right here. First, we are going to use the distributive property whenever we can to remove parentheses. Then we're going to perform the multiplication from the distributive property. So we'll actually multiply them out. And then our last step is going to be to combine like terms. Okay. So let's look at the first problem. We have the product of 3 and the sum of the difference between x and 5 plus 7. Okay. So notice here, this is why we start with the distributive property. The only thing we could do right now is multiply using the distributive property. There's no like terms that we can combine. And also it's easier just to combine the like terms at the end once you have everything written as sums and differences. So let's start with the distributive property on this product. We're going to multiply the 3 times the x and the 3 times the 5. So 3 times x, keep the operation of subtraction, minus 3 times 5 plus 7. So we've used or applied the distributive property. Now we're going to perform the multiplication. Well, 3 times x is 3x. 3 times 5 is 15. And then we have plus 7. Notice I'm bringing the plus 7 down in every expression. Right now we're making a string of equivalent expressions, each one of them getting more simple as we go. So even though we're just working on 3 times x minus 5, Don't leave out that plus 7. You may forget it later, and we also want each line to be equivalent. Okay. So now we have 3x minus 15 plus 7. Well, 15 and 7 are like terms, and we can think of this as a negative 15 plus negative 15. Let me just rewrite this. So 3x plus negative 15 plus 7. Okay? And this is a step we're going to do for a while. Eventually, you probably won't need to do this step, but I want you to see that when we're combining the 15 and the 7, it's not 15 plus 7 is 22. We're thinking of this subtraction sign as adding a negative. So now, negative 15 and 7 are like terms, so we can combine them, and we have 3x plus negative 8. And in our last step, we typically wouldn't leave plus a negative number. We like to write everything as either addition or subtraction. If the first term is negative, like we have here, we write it as a negative as opposed to adding an opposite because there's nothing in front of it. Okay, but here we're going to write this final answer as 3x minus 8. Okay. Now notice if you can look at this line right here and think of it as negative 15 plus 7 is negative 8, which is the same as subtracting 8, that's okay. Okay. I'm pretty good at this by now, I never write these two steps. But I want you to see these two steps, and now that you're first learning this, you might want to write these so you can draw that connection. I can tell you the number one error students make on this is sign errors. Having an addition instead of subtraction, or omitting a negative. Okay, so it's good practice to keep these in order. And it also helps you reinforce your integer skills. Okay? So I suggest that you also, in addition to doing these by hand, check your work on the calculator, and that way if your integer skills, if you're still making a few mistakes, you can catch them on the calculator and learn how to fix those mistakes now. Let's look at the next one, B. So remember our plan, use distributive property, perform multiplication, combine like terms. Okay, so here is multiplication where I would use the distributive property. And I am going to highlight that subtraction sign. Okay, and here's why. Let's rewrite this as 8 plus negative 4 times 3t plus 2. Okay. Now remember, we can rewrite subtraction as addition of the opposite of this number, so that's what I did here. Okay, so we'll discuss at the end. We're going to multiply this out and refer back to the beginning to see why this is the case. So now the multiplication I could perform is distributing negative 4 to this expression. So let's do that. 8 plus negative 4 times 3t. Now the plus sign, negative 4 times 2. Okay. And notice I typically put negative numbers in parentheses, and that way you know that this is representing a negative sign and not a subtraction sign. So we'll frequently be moving back and forth between addition and subtraction by using negatives, but I want to make it clear what that is here. Okay. So now we've distributed, we're going to perform the multiplication. 8 plus, well, to multiply negative 4 and 3t, we multiply the coefficients. Negative 4 times 3 is negative 12t. And here we have negative 4 times 2 is negative 8. So we've performed multiplication, now we want to combine like terms. So here we have a positive 8 and a negative 8. So 8 plus negative 8, well, they're opposites, so they add up to 0. So normally we're going to keep the negative 12t. I'll put plus 0. And normally I wouldn't put the plus 0, but let's just make sure now that we're starting where we know where it comes from, and then eventually we just drop that plus 0. And our simplest form is negative 12t. Okay? So I'd like you to look from this step to this step right here. Okay? So you can think of, and the way I really think of this is instead of rewriting the plus negative 4, I look at the subtraction symbol and multiply, think of that as a negative, and just multiply. I see negative 4 times 3t is negative 12t, and negative 4 times 2 is negative 8. Okay. What can be problematic is make sure that if you do that, sometimes people leave out the addition sign here, okay, and turn it all into multiplication. Okay, so this can just be a little bit confusing. So again, like in the last one, I recommend that if it's subtraction before your distributive property factor, you change it to adding a negative. Learn to multiply this way. Once you learn all of the patterns, okay, and you become more proficient, then you can move on to skipping steps. Okay, let's look at the next one. Okay, so first we want to use the distributive property, and here are my parentheses. Here's what I'm multiplying by, and again there's a minus sign here, so I'm going to think about that as adding a negative. So let's rewrite it as 3x plus 1/2 times, plus negative 1/2, lost a little space there, plus negative 1/2 times 4x plus 4, close parentheses, plus 6. Okay. So I rewrote the subtraction as addition, and then I changed the 1/2 to a negative 1/2, okay, like the coefficient. So now let's perform the multiplication, or sorry, we're just distributing here, which is multiplying. So negative 1/2 times 4x plus negative 1/2 times 4, and then we have the plus 6. So we've distributed the negative 1/2 to each term in the parentheses. Now I'm going to multiply. So the 3x stays the same. Now negative 1/2 times 4x. So I multiply negative 1/2 times 4, and that would be negative 2. Okay. If you need a review on that, you can check that on your calculator. So negative 1/2 times 4 is negative 2 times the x. Now we have plus negative 1/2 times 4, well that's negative 2. And then we have plus 6. Okay. So now I'm going to, we've performed all the multiplication, let's combine like terms. So 3x and negative 2x are like terms, and the constants are like terms. So 3x plus negative 2x, well that is 3 minus 2x. And negative 2 plus 6 is 4. Well, 3 minus 2 is just 1, and we write 1x just as x. So our final result is x plus 4. I'm just going to put that in a box down here. Okay. So notice why, I hope you can see why we call this simplifying now. X plus 4 is much simpler than this original expression, but they're equivalent. Okay, so these are equivalent expressions, and we're going to see in the next video that if we put any number, perhaps 10, 17, a million, in for x in this expression and evaluate, it's equivalent. You'll get the same answer as if you put it in for x here. Okay, so simplifying is going to afford us the opportunity to do less computations in the end. Okay, we'll continue the next 3 in the next video.